figure out the numbers that multiply to be 8, there's a very small number of things that work into that. So what I do is I create a little chart. I call them a T-chart. And it's all the things that I can think of that multiply to be 8, and I always start with 1 and 8. I start with that one because people usually forget it. People usually forget that any number can just be 1 times itself. And then I try to work my way up. So the next biggest number after 1 would be 2. Did 2 times anything equal 8?
Yes.
Yeah, 2 and 4. Then I try the number 3. Then I try the number 3. Did 3 multiply to be 8 ever? No, it doesn't work, right? 3 doesn't go into 8. Then I try the number 4. 4 could go into 8, but I already have 4 on my list. So once I've reached a number that's already on my list, this is my entire chart. These are all the things that multiply to be 8. 1 and 8, 2 and 4. It's a finite amount of things. So if I ask you a question like what adds to be this and multiplies to be that, focus on the multiplies first. And then figure out which one of your combinations would add to be 6. Does that make sense? So my combination for this one would be 2 and 4. The next one. Find 2 numbers that add to be -6 and multiply to be -7. 1 and -7 is correct. And if you're struggling with it, make a T-chart and focus on just the multiplying. So things that multiply to be -7. You could have 1, -7, or you could have -1 and +7. Those are all the things that multiply to be -7. There's no other options. One of those combinations must add to be -6. So this last one, find 2 numbers which add to be -7 and multiply to be 10. How am I ever going to add to be a negative but multiply to be a positive? Yeah, they must both be negative numbers. Okay, because if I'm adding to be a negative but multiplying to be a positive, it must be a negative and a negative. I'm going to focus on the multiplying to be 10. -1 and -10 multiply to be 10, positive 10. What else can multiply to be positive 10? -2 and -5. Would -3 ever multiply to be 10? Would -4 ever multiply to be -10? Would -5 ever multiply to be -10? Or positive? Yeah, and it could, but we already have it on our list, right? So these are all the options you have. Either these are going to add to be -7 or these are going to add to be -7. So the answer would be -2 and -7. Now this might seem like a random skill. Ready? This adding, multiplying to be numbers. Oh, -2 and -5. Yeah, I wrote it wrong. I saw looks of fear in your eyes. So this might seem like a random skill, but it's going to be important when it comes to factoring trinomials. Okay? So that means 3-term polynomials. We're going to need this skill. The way that we do it, I'm going to just slide everything up. You guys see a little bit? Is to first understand that trinomials will be written in a certain format for us. That format we call general form. So when you see a trinomial, in most cases they'll be written like this. So in most cases, you'll have an x squared term, or a y squared term, or something squared. And we say the number in front of it, the coefficient, we call that a. Then we're going to have some x. And its coefficient we call b. And then you're going to have some constant, something that has no x's attached to it. We call that c. to factor a trinomial, you have to know this ax squared plus bx plus. And you have to be able to look at your question and recognize which one's A, which one's B, which one's C. So for this question that's right in front of us, what would B equal? B would equal 3. It's the number attached to the x. What would C equal? 2. Excellent. And what would A equal in this case? 1. Excellent. If there's no number there, but the x squared is there, then it's 1x squared. Today, every question we do is going to have A equal to 1. Tomorrow, A will equal other numbers, and it makes it a little bit harder. Okay, so that means when you're doing your practice booklets or your assignment, after today, you'll only be able to do A equals 1 question, where the number in front of the x squared is 1. All right, let's try to factor this thing. So, to try to factor it, first off, I figure out what the A, B, and C all are. The next thing I do is I use something called the diamond method. It's called the diamond method because you draw a beautiful diamond. On the top of the diamond, you put your A times C value. So A times C goes on the top. What's A? 1. What's C? 2. So 1 times 2 would be 2 on the top of the diamond. The diamond that they've drawn for you on the side, they put A times C. They've shown you there. The bottom of the diamond is your B value. In this case, my B value is 3. The sides of the diamond, you have to figure out. The way you figure them out. The sides of the diamonds are going to be 2 numbers that multiply to give you your top number and add to give you your bottom number. So what 2 numbers would multiply to be 2, but add to be 3? 2 and 1. 1 and 2 also works. The order in which you put them on the side does not matter. As long as they multiply to be the top and add to be the bottom. Diamond method is not factoring. It's a method of organizing your factor. Okay? I don't want you to see this, draw a diamond, and be like, ah, there we go, I factored. You haven't factored. You organize what we're about to do. When we factor, what's another word we use instead of saying factor? We unmultiply, right? We take something and we break it into a multiplication question. When you have a trinomial and you break it into a multiplication question, you're always going to end up with 2 binomials. So I draw my brackets. I know a trinomial will turn into 2 binomials. It's a guarantee. I also know, because I'm pretty good at multiplying, I know that the first term in my trinomial comes from multiplying the first terms of 2 binomials. So how could I ever multiply to become x squared? What would 2 things multiply to be x squared? 2x. It'd be x and x, exactly. So I know that my first terms in each binomial are always going to be x and x, because that's how I create x squared. This is where the diamond comes in handy. Those 2 numbers that we figured out on the sides of the diamonds, those are the 2 numbers that finish off your binomials. So the first binomial would be x plus 2. The second binomial would be x plus 1. So the first terms were x and x, because that creates my x squared. The second term in each binomial is the sides of my diamond. That is my factor answer. We're going to do a bunch of these together. Okay? Factoring using diamond method is probably, I would say number 1, maybe for sure top 3 though, skills that you learn in Math 10C going forward. You have to be able to do this by the time you get to grade 11 or 12. It's used in basically every question once you hit the higher levels of math. So it is an important skill. So we do a lot of it. We do practice a lot. All right, let's do another question that says factor. Anytime I see a question that says factor, the first thing I do is I look at my tree and I say, I'm going to GCF. There's nothing I can take out of all three of these. The next thing I do is I count the number of terms. If it has 4 terms, I'm doing grouping method. If it has 3 terms, I'm doing the diamond method. How many terms are in this question? 3, so I know I'm doing diamond method. Excellent. To do diamond method, I need to understand that there's a thing called general form, where you have ax squared plus bx plus c. And I need to know what a, b, and c all are. In this case, a equals 1, b equals 6, c equals -8. I use those values to fill out the top and the bottom of my diamond. So I draw a beautiful diamond. It's already there for you. On the top of the diamond goes a times c. So the top of my diamond in this question would be 1 times -8, -8. The bottom of my diamond is b. B in this question is 7. The sides of my diamond, I need 2 things that multiply to be -8 and add to be 7. If you can't figure it out instantly or quickly, make a chart of the things that multiply to be -8, and one of them will add to be 7. One of your combinations will work. So if we try it, things that multiply to be -8, we have -1 and 8, we have 1 and -8, -2 and 4, we have 2 and negative. One of those combinations must add to be 7. So we focus on the multiplication. Which one of these could I add to be 7? 1 and -8. If you try to focus on the addition first, you'll struggle. Focus on the multiplication, make a chart, and then narrow it down. It would be -1 and positive. I said -7 out loud. The reason we use the diamond method is to help us factor. Anytime I factor in trinomial, I know I'm going to end up with 2 binomials. So I draw in my brackets. I know that's going to happen. I'm also very good at multiplying. So I know that the first term comes from multiplying the first 2 terms together. So 2 things that would multiply to be x squared would be x and x. Now I need to figure out what the next 2 things are in my binomials. They come from where? The numbers in my diamonds. -1, +8. That is my factored answer. I took a trinomial, I turned it into 2 binomials multiplied together. If you're not sure if you did it right, you could multiply your binomials together, and it should give you your original question. Anybody have any questions about the diamond method? Alright, we're going to do one more together, and then we're going to let you try one on your own, and then we're going to do another one together. If you do number 4 on your own, you're probably going to make a mistake, because there's a trick to it. So, number 2. The question says factor. I recognize it's a trinomial, and I need to do diamond method. The top of my diamond is my A times my C. My A is 1, my C is 12, the top is 12. The bottom of my diamond is B. My B value is 7. Things that multiply to be 12 and add to be 7 are 3 and 4. now that I have my diamonds, I know when factoring a trinomial, I would get 2 binomials. I also know the first term comes from the first terms of my binomial. X squared is only going to happen if I have x times x in my first term. The second terms are the trickier ones. And the way we know where the second terms come from is from that diamond that we made. It comes from 3 is 4. So plus 3 plus 4. That is a factored term. Do you have any questions before I let you try one on your own? Okay, give number 3 a shot. To do number 3, we look at this. We see a trinomial. To factor a trinomial, we do a diamond. We draw out a diamond. On the top, we go a times c, which would be 3. On the bottom, we go our b value, which would be 4. I saw a lot of people did really good at that. And then I saw a group of people who were struggling to figure out the size. 2 numbers that multiply to be 3 and add to be 4. Focus on the multiplication. What are the only things that multiply to be 3? 1 and 3, right? So the size of the diamond must be 1, 3. I then know that anytime I factor a trinomial, I'm going to get 2 binomials. The first term in each binomial creates the first term of my trinomial. So if I want to get an x squared, my first terms must be x and x. The second term in each binomial comes from the diamond. It comes from those side values. So it's going to be x plus 1, x plus 3. That is my factored trinomial. Look how you guys did pretty good on that. That's awesome. We're going to slide it up so I can have a little bit more space. I saw people trying number 4. Number 4 has a trick to it. The trick to number 4 is remembering our factoring tree. The first step to any factoring problem is do a GC. So you need to look at your beautiful trinomial, and you need to check to see if there's a number that can divide into all of these numbers. Is there a number that divides into 3, 27, and 60? Can 3 can divide into all of those. I'm also going to teach you something important right now. And it's if you want to factor a trinomial, you need a positive a value. Your a value must be positive. So that means I don't want to just factor a 3 out. I want to factor out a negative 3. So if I take a negative 3 away from all of those numbers, that's called doing a GCF. I would be left with y squared for the first term, negative 9y for the second term, and plus 20 from the third term. I got those numbers by dividing everything by negative 3. So I went 27 divided by negative 3 is negative 9. Negative 60 divided by negative 3 is positive 20. That's called doing a GCF. Now that we've taken a GCF, I have a trinomial right there that I've highlighted in red. I need to factor that trinomial. It's a trinomial, so I do diamond method. A times C goes on the top, so 20. B goes on the bottom, negative 9. Things that multiply to be 20 and add to be negative 9. Negative 4 and negative 5. That means this trinomial that I've highlighted in red would change to be x minus 4, x minus 5. What about at -3. Yeah, what do you think I should do? Ali, you're right. It's just going to go in front of the brackets. Remember, this is multiplication, right? So I now have 3 times a trinomial, and I've now changed that trinomial to be 2 things multiplied. But it was still being multiplied by -3. Yeah, okay.
So always changing, or what's the X? No other question.
Sorry, I would leave it as a Y. Yeah, it really makes no difference, but I just always, like mentally, I'm always changing things to X's. You're going to see that happen more than once. I should have left these as Y's. If you accidentally ever change them to another letter, you'd be 100% okay. I wouldn't punish you for it. The other thing is, if it's multiple choice, you're only going to see answers in terms of Y, so it'll be like, I'm not going to say, is the answer Y minus 4, Y minus 5, or X minus 4, X minus 5, right? Like, I'm not going to try to trick you. Yeah.
Where's the 4 and 5?
The 4 and 5, good question. So, the sides of the diamond, these numbers, they created these numbers right here. I got them because they're the 2 numbers that multiply to be 20 and add to be -9. So that's how I figured out what they were. Yeah. Any more questions? Okay. I want you to try to factor this one. What's the first type of factor you should try? GCF. So check to see if there's a number that can come out of all of them, and then see if you can do the whole question by yourself. If you feel confident in that, try number 6. If you get stuck on 6, that's okay. You guys did a pretty decent job with your GCF. Okay, so that's good. You look at this question, the number that can divide into 2, 10, and 12 is 2. When you do that, it leaves you with x squared plus 5x plus 6. Now I can do my diamond method. But you always start with the greatest common factor, so you have your new A, B, and C values. You have to GCF first. Every question we do, whether it's grouping method or diamond method or what we're going to learn called difference of squares, you always do a GCF first. Now we have this thing in here. A times C goes on the top, 6. B goes on the bottom. I want 2 numbers that multiply to be 6 but add to be 5. 2 and 3. Now that I've made my diamond, I turn my diamond into a solution. The solution's going to have a 2 out front. This 2 out front. And then the trinomial will turn into 2 binomials. 2 numbers that would multiply to give me x squared would be x and x. The sides of the diamond now join into the binomials to give me x plus 2, x plus. That would be my factor solution. Because I GCF'd it. So I divided everything by 2, but then I had to represent that I divided everything by 2 somehow. So I represent it by multiplying, so it's still balancing it. Alright, number 6. What makes number 6 so hard?
There's 2 squares.
Yeah, there's 2 squares. There's another letter in here, right? I have x's, which we're used to, but then I have these y's as well. And we haven't seen y squareds in our terms. We're going to try, first off, to treat this as if the y's don't exist. Okay, it's just to see what happens. So pretend the y's weren't there. This y is not here, and this y is not here. I know how to do that question, right? I do a diamond, I put A times C on the top, negative 63. I put B on the bottom, 2. I find 2 numbers that multiply to be negative 63 and add to be 2. That's a harder one, so I would make a chart for negative 63. I'd say 1 and 63 works. I would say 3 and 21 works. 4 doesn't work, 5 doesn't work, 7 and 9 8 doesn't work, but 9 is already on my list. Some combination of these, where one of them is negative and one of them is positive, would add to give me 2. Are any of these 2 apart? Negative 7 and positive 9 are 2 apart. So negative 7, positive 9 are the sides of my diamond. When I get stuck on my diamond, I make a multiplication chart. And it makes it so much easier. And I'm guessing and checking in my calculator to make that chart. All right, so if this was just a regular old question, I know that I'm going to get 2 binomials. And I know my first term has to create x squared. So I'm going to say, well, to create x squared, I go x is x. I then also know the sides of my diamonds become the second things of my binomials. So negative 7 and positive. That's how I would do it in a world where the y's didn't exist. But these y's do exist. So I need to know something else about multiplying. I need to understand that my c value, or my last term, comes from multiplying the last terms of my binomials together. Just like the first term came from the first terms together, the last term comes from the last terms together. So if I wanted to get a y squared in my last term, what would I have to put in to my binomials? A y into each of the last terms. Because that would create my y squared. Now, some people are like, but how'd you get xy, right? Those middle terms. If you were to multiply these together and create an area diagram, you would at some point have x times 9y. That would create 9xy. At some point, you'd have negative 7y times x. That would give you negative 7xy. And then you'd have to add your like terms. But you get those other ones by multiplying the middles together. But the first and the last always come from multiplying the firsts and the lasts. That's as hard as today gets. Okay. We're going to talk about this next question. It is a question that you'll probably see on a test at one point. Okay. So it says, determine possible values of b, which would make the polynomial factorable. So they're saying replace b with a number. And if you were to replace b with a number, it has to actually make it so it's factorable. Let's just for fun pretend we're going to factor that. It's going to be a diamond method question, correct? A times c is going to go on the top, so I have 18 on the top. And do I know the number that's going to go on the bottom? I don't, right? That's what my b value is. So they're saying what values could possibly go on the bottom? Does anybody have one answer that they can think of and then want to explain how they figured that out? Yeah, go ahead. There's going to be a lot of answers. So you're looking at numbers that add, right? So I could put a lot of numbers in there and add. But what do those numbers have to do? They have to multiply to be 18. So what numbers multiply to be 18? I always start with 1 and 18. And then 2 and 9 is also fantastic. What else would work? 3 and 6 would definitely work. Is there any other ones?
Could you say, for like the highest terms of like going to 18, just like the highest, it's like 3 and 6 or?
Oh, for this one, it's just asking possible values. So you could choose any of these. So, for instance, if I said the sides of my diamonds are going to be 18 and 1, what's a possible value of b? Maybe 1 plus 18, right? Multiply to 18, add to b 19. So that's one possible answer. 2 and 9 multiplied to be 18, what do they add to be? 11 is one possible answer for B. 3 and 6 multiplied to be 18, what do they add to B? So 9 is a possible answer. These are all possible answers for B that would make it work. There's more.
4 and 4.
Close, that's 16.
Sorry, yeah, that's
Give me a hint. Yeah, there we go. What did you say? The negative versions. -1 and -18 would multiply to be positive 18. -2 and -9 would multiply to be 18. -3 and -6 would multiply to be positive 18. So that means you could also have negative versions of these B values. So there's 6 possible answers in this question.
But it says
Does it say positive?
it says like for like the plus, you have to plus the x. That's doing negative.
You're adding a negative number. So you could have a negative B answer. The formatting is saying that you're adding it. So just because it says plus in the question, you could change that to be a negative by adding a negative number. The only time you wouldn't do that is if it said right in the question, B is a positive value. Like it has to explicitly actually say that. That means B's are all possible B values. There's 6 possible B values. It takes a good understanding of what you're doing to be able to answer a question like that. There's a good chance you get one question like that on a test to kind of separate to see who's really understanding what's going on. For B, we're just going to talk about B. We would do the same thing, right? We would create a diamond. But this time we know we have 10 on the bottom, and we don't know what our top is. This one's harder. The first one for sure has 6 answers, only those 6 answers. Why would the second one be harder to do? If you're starting with addition. So things that add to be 10, we talked about this. How many things could add to be 10? A lot. An infinite amount. Right? Because I can go 5 and 5. That would add to be 10. Think it. You go 5 plus 5, that would work. You could do 4 plus 6, that would work. You could do 3 plus 7, that would work. You could do 2 plus 8, that would work. You could do 1 plus 9, that would work. You could do 0 plus 10, that would work. But then you can start going into the negatives, and you could go -1 plus 11, -2 plus 12 would work. And I could do that chart forever. So if I was to ask you how many possible things can I put into the top of this diamond, into my C value here, the answer would be an infinite number of things.
So it's not your answer.
Your answer would be infinite. So how many possible values? You would say an infinite number of values. I would just write infinite. If they asked me for an example, then I would say, well, 5 plus 5, if I was to multiply, that would be 25. That's one example of an answer. But I have an infinite number of answers.
So which one is how many we can have or which?
This one says how many, so determine the possible values. So this one has an infinite number.
So
If it said,
6 for the first one.
the first one would be 6, there's 6 answers. There's 6 possible answers. On a test, it'll make it very clear whether it wants how many are there, or it'll say, give us an example. And then if you said 19, you'd be right. But if Hannah said 11, she'd still be right. And if Kieran said 9, he'd still be right. I mean, like, you could give different answers, and you'd all still get the right one. I'm going to put a list of things